Good morning, ladies and gentlemen. This is Ben Keyser with Applied Flow Technology. I hope that you all are doing well and having a wonderful day or morning or afternoon or evening or wherever you are in the world. Anyway, thank you very much for joining me. I'm really excited to present the new features of AFT Fathom 10 for everyone. A couple of things. First off, this webinar is being recorded, and that way later on, if you want to watch it again, you'll be sent a link to the recording. If you are supposed to be here but you're not attending right now, you'll be sent a recording and you'll see that once you get it. The next thing is I have included a few handouts for you all. There are 4 PDFs that each of you should have access to with today's webinar. One is a Fathom 10 new features PDF. Then there should be a couple of data sheets, both for Fathom itself as well as the Fathom add-on modules. And then the last one, I actually included a PDF of my presentation. So that way you'll be able to have that on file for later. If you're watching the recorded version of this and you want to copy my presentation, please email me at benkeiser@aft.com. That's benkeiser@aft.com. I'll be happy to send it to you. All right, we've got lots of stuff to talk about, so I'm just going to go ahead and jump right in. And a couple of newsworthy note items first. Fathom 10 was released back in mid-May. We've had a few maintenance releases since then. The latest maintenance release was pushed out on July 13th of 2018 to address various things that needed to be updated, and so everything's working really nicely. Fathom 10 has been out for a little while now. AFT Aero 7 was released earlier this week and is now available. And as you can see, I've prepared a picture. If you go to the downloads menu on our website and then under current versions, you'll find the AFT Aero latest release. And as you can see, Fathom or Aero 7 is now available, the release date being July 23rd. So if you have a license of AFT Aero 7, you can download that and install it. And a couple of important things is that many of the new features that I'm discussing today are going to be present in AFT Aero as well. So when you see the new features today, you'll be able to use those same features in Aero 7. And so a lot of that's going to be crossed over. We will be doing a Aero 7 new features webinar separately in a few weeks. So make sure that you stay tuned for that. Another newsworthy item is AFT Impulse 7 is very shortly about to be released as well. We're thinking probably late third quarter, early fourth quarter of this year. So stay tuned to that, and that way you'll be able to get the latest updates in Impulse as well. Where can you find useful pieces of information on our website, aft.com. Under Learning Center, under webinars, you can register for our upcoming webinars. There's also tips and tricks area that allows you to find articles that will teach you about how to use various features in more effective ways. And there was another item that I was wanting to mention, but I'm just so excited about Fathom 10, I can't remember what it is. So if I think of it, I'll let you know. Anyway, moving forward, if you want to download AFT Fathom 10, first you have to make sure that you are registered and logged into our website. So if it does not say your name in the upper right-hand corner of our website, it'll say log in. You'll have to click that login button and then register and fill out the registration form. It's a really super quick process. Once you're registered, you'll be able to get in and you'll be able to download the latest release. You can keep tabs on the release notes. That way you can see all the various updates that we've done for that particular release. This is a slightly outdated screenshot, and so you'll see that the latest release is July 13th. And then this area is also very important, is to sign up for notifications. That way, whenever we put out another maintenance release of Fathom or Aero 7 for that matter, you'll be sent an email. That way you can download and get the latest update. The registration for our webpage, it's not restricted to anyone. So even if you don't have installation privileges on your computer, you can still download the latest version. Then you can give it to your IT person, and then they can install it. So keep track of those things, and that's how you'll be able to stay up to date, which is a very important thing to do. All right, so what new features are we going to be talking about today? There's a lot of significant ones I'm going to be touching on. And so we'll be talking about, I almost knocked over my water with my microphone there. We'll be talking about some general new features, including how you can set up default preferences from the startup window. We'll be talking about the new NIST RefProp fluids that you can work with, various new features for some junctions, notably the pump property window. We've completely redesigned that, made a lot more streamlined, and we've added on some additional features. You can now do a intermediate pressure extraction flow. Talk about what that means. You can now account for acceleration head loss for positive displacement pumps. You can show the preferred operating range and allowable operating range for your pumps. View summaries of codes and standards used in models. We have a lot of standards that are already built in, such as viscosity corrections and things like that. If there's a particular standard that is used in your model, we're going to report which one it is. That way you'll see it in your results. And we're going to be adding to that over time. So if any of you want us to be able to add in a particular standard or code that it's important to you, email us and we'll work on getting that integrated as well. We've got some new capabilities with the relief valve model, and you can now select a relief valve based upon the orifice size via the API 526 standards. So I'll show you that very quickly. New transient things are available for the AFT Fathom extended time simulation module, and you can do design alert highlighting for the XTS module. The new one that's really powerful is our new multi-condition event manager. This is where you can do some really fancy types of transients for modeling, various and or types of logic with the XTS module. Lots of primary window new features. There's a brand new isometric grid that you can work with. You can change colors of different scenarios. That way, whenever you go to the workspace of a different scenario, you'll know which one you're in based upon the color that you've specified. There's new symbols that tell you if you've got additional fittings on a pipe, new model data input parameters. You can find pipes and junctions on the workspace from the model data window. The visual report control is a lot more user-friendly now as well. There's also significant amounts of new features for pipes and junctions, Excel integration, and model importing. So various piping new features include automatic heat transfer coefficient calculation. That's where you can put in your ambient temperature and your wind speed, and that will calculate your external heat transfer coefficient for you. There's also new buried pipe and new heat tracing thermal models that you can work with. There's some new intermediate elevation pipe or intermediate pipe elevation options that makes that a lot easier. I'll show you that. There's some additional pipe material standards that are built in. Various model importing capabilities that you can work with. Piping component files, Caesar2 neutral files, EPANet. The model importing, that's probably one of the best new features of Fathom 10 and Aero 7 right here. And so I'm going to make you all listen to the whole webinar because I'm not going to talk about this stuff until the very end. So stay with me and you'll see some really cool new capabilities that will save you tons of time when it comes to building the model and the whole layout itself. There are some dramatic enhancements in the Excel integration. There's a brand new Fathom Excel import workbook template that you can work from. So instead of having to remember a whole bunch of codes to import Excel changes, you can still do that if you want, but now you can actually do it with keywords. It's a lot easier. You can also, a new enhancement is rather than only importing Excel changes to one particular scenario, you can do it with multiple scenarios all at the same time. So that will streamline your model input definition process. There's a brand new Excel export manager, and I'm going to show a few examples today on how you can take output data from Excel or from Fathom rather, and it can be exported automatically into Excel for you. It'll make it a lot easier to do your side calculations. Lots of stuff that we're going to be covering today, so get ready to drink from a fire hose. Again, keep an eye out for this recorded webinar, because that way you'll be able to go in here and see how to use a lot of these new features. So let's get started. Covering the basics, modeling preferences and ref prop. So one of the new features that we integrated was in the startup window right here. When you first run Fathom, you can now configure what your modeling preferences are directly from that window. I'm going to show you that here in a sec. Also, there's a brand new thermophysical property database available. It's RefProp from NIST. Give me a quick second here. Hang on there with me, everybody. I need to pause this for a second. Okay, sorry about that. I was getting some feedback, hearing some sound from somebody else who might have not been muted. So I've muted all of you, so that way it should eliminate any feedback here on the webinar. So hopefully you all can still hear me. Let's go ahead and keep marching forward. The new fluid properties from NIST are available as a part of the standard software. You don't have to buy an extra license. ChemPack is a extra license that you would have to buy, and it's been around for a long time. Very powerful fluid database. It's got about 700 different fluids. RefProp has maybe about 200 or so, but they're very well trusted fluid properties, and it's integrated directly into software without requiring an extra license. So let me show you these couple of things here with Fathom itself. So here's our startup window. As I mentioned, the modeling preferences can be adjusted by clicking on Modify. So when you click on that, it'll pull out this panel. This is where you can configure your unit system. There may be various common types of units that you work with a lot, depending on the industry that you're working in, and you can take advantage of that right here. You can set the language of the software that you want to work with. There's the two-dimensional ISO grid. You can set a default pipe material. If you do fire protection systems, you can turn on your NFPA settings. All that can be configured. And so one thing I want you to keep in mind is that if you're configuring your units from the startup window here, every single time that you open a brand new model, it's going to remember those configurations. So if you ever want to go back to the way that it was originally in Fathom, you can always go to the Tools menu and set your user options back to Fathom defaults for that model. But then once you open up Fathom again, it's going to resort to these parameters that you've set. So make sure that if you're going to set these parameters, that's exactly really what you want to work with all the time. All right, I'm going to pick a different pen color. That way it's a little bit easier to see. So I'm just going to keep things the way that they are. The way that you can access NIST is simply by going to the System Properties window. And here's your NIST RefProp fluid properties. All of these are very accurate thermophysical properties. You can click on search and type in a fluid name. That'll help you find the fluid that you want to work with a lot easier. These fluids know where the saturation lines are. So if you're doing heat transfer and the temperatures are getting too high, then Fathom can warn you if you are vaporizing in your fluid with higher temperatures. So that's an advantage of using the fluids from NIST RefProp. The other advantage is you can click on create new mixture and add, and this is where you can do multiple component mixtures of different RefProp fluids on a mass or mole fraction basis. So once you do your mixture on a mass or mole fraction basis, it saves you a ton of time and makes it a lot easier to determine your mixture properties rather than you having to do it on your own. So if you want more accuracy, you can work with NIST, and that's available to you all. It's going to be available it's available in Arrow 7 as well. All right, what's the next new features here? Pumps. So we have completely redesigned our pump property window. This is an example of how you can model positive displacement pumps more explicitly. And you can do a fixed flow rate for your PD pump flow. But the other powerful capabilities that you can now account for your acceleration head loss. So that's a new feature. Another thing that you can do is you can see how it's more streamlined for sizing. So you can pick if you're going to do a centrifugal pump or a PD pump. If you're either doing a pump curve or sizing, those are different options that make it a little bit more clear for you with what you're doing. This is an example of if you're sizing a pump. And then finally, if you did an interstage bleed, that's where you check the box for this option right here. You might need to take off a little bit of fluid from a multi-stage pump where it's going to a different process like this, where you don't need as high of a pressure as you would need at the very outlet of the pump. And so this is a new capability that allows you to take off a little bit of flow from your pump and use it for another process where it doesn't need as high of a pressure. So I'm going to show you an example of what that looks like here in a minute. All right, so let me go ahead and pull up my model here. Give me one quick second. And let's see. When you're doing webinars, it's really helpful when you're able to have multiple screens. That way you can get things out of the way. So I have a ton of models that I'm going to be showing today, so this will help me keep track of which ones I'm going to show. Okay, so first thing that I'm going to show is a model that demonstrates the PD pump behavior as well as the POR stuff. So let me browse to that model really quick. All right. So first example is if you just draw a pump on the workspace, here's what the new pump property window looks like. So as you can see, it's completely redesigned. You've got your centrifugal or rotordynamic pump. If you do a pump curve, that's where you can enter your pump curve data in the window. If you do sizing, then it's a little bit more streamlined for that. And then for positive displacement pumps, this is where you can do your acceleration head loss. You can pick your different types of PD pumps that you're dealing with, a K value of the different fluid, and then a pump speed. And that way your acceleration head loss can be calculated. So that's what I've done in this particular model here. This is a positive displacement pump. And my positive displacement pump is operating at 10 gallons per minute. I just picked values at random. So it's a simplex, hot water, and the pump speed is 1800 RPM. So those are the parameters that I set up. And when you run the model, this is how it looks. Here's your pump results, and as you can see, I have a new column that's available for acceleration head. So your acceleration head is 63.25 feet. There's also another area where you can find the acceleration head. That's on this applied standards tab. This is another new feature that I'll talk about in a minute. And so this is telling you which particular standard we are using in order to calculate the acceleration head for your PD pump. So that gives you a little bit more information there. If you were to go to the graph results window, there's some new graphs that you could do for those types of positive displacement pumps. So I've already generated that. Let me regenerate it here. This is my positive displacement pump. No, it's not actually. Let me open up a new graph here. Let's see. Let me try something real quick. Oh, I'm sorry. I was looking for a type of graph that shows you what the interstage bleed does. So I was thinking a little bit ahead of myself. So this is basically all there is to it for the positive displacement pump, where it'll calculate what the acceleration head loss is for you, and it'll take that into account for your pump performance with a PD pump. So that's basically it for a positive displacement. Next is for pump curves. You can now include your preferred operating range. And so if I open up my pump here, you can see that I've got a head curve, MPSH curve, and an efficiency curve. So for my head curve, if you go into the pump configuration window where you enter all your data, the configuration data tab is where you can take advantage of implementing your preferred operating range as well as your allowable operating range. So for this model here, I've selected the ANSI HI standard of my centrifugal pump to show my preferred operating range. So this is all about your proximity to the best efficiency point of your pump. So I've already got that all set up. When I run my model here, it's going to do a couple things. One is it brings me back to that same new applied standards tab. So this tells me that pump 2 is within my operating range for the POR between 70% and 120%. So that is my boundaries of where I want to make sure that I'm operating my pump at. So I go to my, whoops, I didn't mean to do an arrow. If I go to my pump summary tab, you can see right here that this has always been available, your BEP proximity, but now the standard is telling you if you're exactly within that range or not. The other new feature with the preferred or allowable operating range is when you go to the graph results window, this is the graph item that I pre-generated. So when you include the preferred operating range or allowable operating range, you can see that you have these little X's right here. That represents the preferred operating range for where your pump has to be. So if this is my best efficiency point right here, here's where I'm operating, and I can see that I'm within the 2 X's for the preferred operating range. So that's good. Just one of the many new capabilities there. All right, let me talk about the interstage bleed. Let me pull up that model here really quick. Pump with interstage bleed. Okay, so here's where I have a situation that I've got a multi-stage pump, and at an intermediate stage, I'm going to take off a little bit of flow, which is used for another process, just 50 gallons per minute. And the key thing is, I don't need to have such a high pressure for that flow. So it's not being taken off all in the discharge. So the way that you set this up is you would open up your upstream, your suction side, and you would check this box for using a interstage bleed right here. You would enter a pump curve with the enter curve data window, just like you normally do. And the key thing that I want to point out is that this pump curve that you see here, this is for stages that are upstream of the bleed flow. Okay, so that's your full manufacturer's pump curve right there. Next, you would specify what the next pump stages are, which is based upon J5. That is this guy right here. So now if I open up J5, this just tells me that this is the discharge pump that has the downstream stages after the discharge flow. Again, this pump curve that you see right here, that is the original manufacturer's pump curve without the bleed takeoff. So in reality, when you run your model, the performance that you're going to see on that downstream stages is going to be a little bit less than your original curve. And you can actually plot that in the graph results window. Okay, so when I run my model, here's what things look like. Is if I go to my pump summary, you can see how your flow rate's a little bit different. Your initial suction flow is 540 gallons per minute. We took off 50 gallons per minute, so leaving the discharge, you've got 491. Now, it's a lot easier to see the results when you're doing a pump and system curve in this case. So let me switch over to the graph results window. So this is what I was expecting to see, is when I regenerated my graph. So if you click on the curve type drop-down menu, there are some additional options since you have multiple pumps on the workspace. As you can see, there's a series configurations you can do. You can do a parallel composite pump and system curve, all that stuff that has been in Fathom since a very, very long time. But this is the new one, Interstage Bleed. So when you pick Interstage Bleed, you select the pump that deals with, which is J2 and J5. And when you generate it, here you can see that you've got multiple curves and a couple of X's. So let's break this down and look at it one by one. So if I turn all of these curves off, here's my bleed head, okay? So that is your original manufacturer's pump curve. If you were to close off the bleed and have everything going through the main pump and not do an intermediate takeoff, this is how you can see that those curves are the same manufacturer curve, okay? Now, after you do take off a little bit of that flow for the interstage bleed, this is how it shifts to your pump curve. So this is the actual operation right here of your pump curve on the downstream stages after the takeoff has been taken off. Okay. The next couple of things is you can see where your operating points are. If you click on the button right here, this is where your bleed operating flow rate is, and then that's your discharge operating flow. So lots of information on this graph. That's what it looks like if you're dealing with a interstage flow for your pumps. All right. Enough with stuff on pumps. Let me keep marching forward here. I'm going to open up a new instance of Fathom here. One additional thing that I'm going to show with regard to the applicable standards is this example where I'm using viscosity corrections. So in this model here, I have a very highly viscous fluid, 500 centipoise. Viscosity corrections have been available in Fathom for a long time because your pump test fluid that you get your curve from, this is going to be based on water. And when you are pumping a more viscous fluid, you have to derate your pump. Well, if you go to the optional tab, this is where you have always been able to apply viscosity corrections to derate your pump for you in Fathom. Well, as always, um, as previous versions, if you went to the pump summary tab, you're still going to see the same correction factors that you saw before. But again, the new thing here is the applicable standards tab. So now you can see how the standard changes based upon the one that I'm using. So if I'm doing the viscosity corrections, that's the Hydraulic Institute standard that I'm working with. So again, very useful. Let us know which standards that you work with, and we'll continually build on that over time. All right, the next new feature for junctions is with regard to relief valves. So if I was to just drag and drop a relief valve here on my workspace and I open that guy up, go to the loss model tab. If you pick the CDA value for the loss model option, then this is where you can choose your API designation. And so when you click on that drop-down menu, let me turn my pen off, you can pick any of these letters. That's the different relief valve that you'll be working with, and that will change your effective orifice area. And then you can define what your discharge coefficient is. Maybe it's 0.6, and there's your CDA value. So that's the new loss model available for relief valves. Like I said, there's a lot of these new features that are very basic and quick and easy to show, and then there are some other ones that are a little bit more detailed. So that's why a lot of this stuff is really quick and easy. All right, coming back to the presentation slides here. Let's talk a little bit about the extended time simulation module. If you don't know what the heck that is, go to our website, and then under AFT.com, under products, you can read about our AFT software overview. This will give you a really good overview of all of the different products that we offer. When you click on any of those, you'll see that each of these products has a number of additional add-on modules. And if you scroll down here, you can see information about the goal seeking control module, settling slurry, and extended time simulation. So the next two main new features that I'm going to be showing you are with relation to the XTS module. All right, turn off my drawings, go back to my pen, go back to my presentation. So here's the new thing that's really powerful, is when you're doing a transient simulation, you want to do a design alert. That way it'll flag your attention to potential operating problems. So in this particular scenario, I have a situation where the yellow line shows how my flow rate is increasing over time, and then it decreases. And then at a later time during the day, it increases again and then drops back down. Well, as the flow demand increases, your pressure throughout the system is going to change accordingly. So the red line is my pressure at a certain point in the system. That pressure drops as flows go up, and then as flows go down, my pressure increases. Well, if you were to put in a design alert for your vapor pressure, you can see right here when you plot your vapor pressure with this graph that you have a major problem. When you have flows that are really, really high, during that time frame, you are cavitating like crazy. Your pressures are way below your vapor pressure for those time frames. You've got a major operating issue that you need to deal with. So you're not going to actually be able to get those high demand flows. You're going to have to change your system. So one of the new features that came out of Fathom 10 is the ability to cross-plot your design alert with the graphing capabilities. The other thing that is really useful is not only will it tell you that your design alert is being violated in the output window, as it usually would, it's going to now highlight those design alert violations in the transient data. So that's a new feature that'll highlight those problems, and it's important, and that's where you can see additional design alert enhancements. The next Fathom 10 XTS feature is a bit more exciting. Multi-condition events. So this is where you want to work with maybe some and or logic when you're dealing with your flow models. Excuse me. If you ever have a chance to visit Colorado, that's where our office is located. We are at a very high altitude. We are known as the Mile High City up in Denver, 5,280 feet. Colorado Springs, where AFT is located, is at about between 6,000 and 7,000 feet, depending on where you're at in the city. If you ever get a chance to visit Colorado Springs, or Denver for that matter, drink tons and tons of water, because it's a very high altitude and it's also a very dry climate. And so as I do these webinars, I talk and talk, my voice gets a little scratchy, so I had to take a quick minute to take a swig of some water and rehydrate. So if you're ever out here, make sure you stay hydrated. All right, back to the model here. Here's the situation I'm working with. I've got a pump, and I'm delivering flow to two separate discharge tanks. Because I'm using the XTS module, I can model finite tanks with an actual geometry right here. So if I specify a tank height, it is possible that those tanks can overfill. And if you overfill, Fathom will warn you about that. And if it's a hazardous chemical, or even if it's water itself, you don't want your tanks to overfill. So here's my scenario. Is in this particular model, I have a valve that I want to shut off for two different reasons. Okay, my desired liquid height that I need in my tank is 15 feet. So the tanks are 30 feet high. I need 15 feet of water in each of those tanks for some process, and they are initially empty. Okay, so I'm filling up the tanks over time. One reason that I want the valve to close and shut off flow is if both of my tanks get to have at least 15 feet of water in them. Okay, so that's my and logic. The other reason why I'd want this valve to close is if the liquid heights get to be too high. Well, with my tank heights being 30 feet, let's say one tank fills up a lot faster than the other. Well, I want the valve to shut off if either of those two tanks were to get above 27 feet. So let me go and open up the model and show you how I did that. All right, so here's Fathom. Let me go to the model here. All right, turn this guy on. Okay, so in this scenario, this is where my tank height needs to be 15 feet. Okay, if you were to open up these tanks, here's what the geometry looks like. This is all stuff that was with redesigned in Fathom 9, so you can do your finite tank geometry with the XTS module. But for my valve, this is where I'm doing my multi-condition events. So on the transient tab, my event type that I chose was multi-condition. All right. If you go to the multi-condition event manager, the process is to create a simple event. Well, first things first is if my discharge tank 1 is too high, that's one reason that the valve is going to close. So I set up my event criteria. You give it a name, you pick the event type, reservoir liquid height. The condition is if it gets to be greater than or equal to 27 feet, and then you pick a particular reservoir, that's one event that could happen. All right. The other is to do the other tank, where if my other tank is greater than 27 feet, that's my other event. The other two is my desired fill heights. So my desired fill heights being 15 feet for tank 1 and 15 feet for tank 2. After you go through the process of defining these 4 events, the next step is to create a multi-condition event. So that's where you would choose your and or logic. So you would give your multi-condition event a name. So here I'm calling it shut off the valve too high. So there's or logic for this. All right. So it's going to shut off the valve if the tank 1 is too high or tank 2 is too high. So that's the first piece. Second piece is to shut off my valve if I actually get the correct height. And for that, both the criteria has to be met. So if my desired tank height in tank 1 and tank 2 are met, that's the other reason to shut off the valve. Well, I have to do one more step because I want to make sure that the valve can shut off based upon either the or criteria or the and criteria. So once I create these 2 multi-condition events, I would create a third multi-condition event right down here, and I called it shut off on too high or just right. And so this multi-condition event is the one that I'm actually going to use. So I have or logic specified, and it's going to be either based upon this one for too high or this one for the correct height. My advice is when you first start working on this, click on help and read the help file on how to use those multi-condition events. That will guide you on how to set this up. So now that this is set up, we want to figure out when is that valve going to close and why. So I am running my simulation for 120 minutes, and my data points are at every minute along the way. So I run my XTS module here. It solves fairly quickly. XTS is completely neglecting anything water hammer related. So with my time step being every minute, when you're transitioning from one time step to another, when you go minute to minute, that might be enough time for your whole system to come to a new steady state. So that's what XTS does, is it captures a whole picture of steady state simulations over time. And as long as your system is changing very slowly and given enough time for those water hammer waves to dampen out, then XTS will give you a very good picture of what's going to happen. So if I go to my output tab, when does my valve close? Well, based on my event messages, my valve closes at 97 minutes. Okay, so if I go to my graph results window, I've already got a pre-generated graph for my liquid height versus time in both tanks. So as you can see here, if I go along in time, my valve closes at 97 minutes, which is right here. Let me draw a line at that point. So 97 minutes, pretend that line is vertical. Okay, well, what's going on here? If we track what the liquid height is doing, my liquid height in tank 2, the further reservoir, it's not at 15 feet yet. Okay, so I don't have enough flow or enough liquid height in my discharge tank to shut off the valve. So the reason why that valve is shutting off is because my liquid height is it shuts off at 15 or 97. So here's 97. So my line is not exactly where it's supposed to be. So at 97, this is the time where I hit 15 feet in the second discharge tank. Both of them have the required 15-foot liquid height that I need. That's why the valve shuts off. Okay. Now, let's change the situation. Let's say that we don't need 15 feet, we actually need 20 feet. Well, what happens if one of these tanks fills up to be too much? If I open up my valve again, I can go back to my multi-condition event manager, and I simply change my desired fill tank height to be 20 feet. So let's say 20 feet for that one and 20 feet for this one. How does this impact the way that the valve changes? Well, let's run the model and take a look. While this is running, I'm going to multitask and talk about the next thing is our new isometric grid. So this is a really cool capability in AFT Fathom. Let me go to presentation mode and go through this bit by bit. So the first thing with the isometric grid is you can see that you have ISO grid, and if you draw a pipe from one point to another, you're going to see a little red dotted line that shows up. That little red dotted line is going to tell you what your pipe is going to look like after you finish drawing it. So once you have drawn the point to right here and you let go of your pipe, that's what it looks like. Well, the cool thing is, as you have dragged the pipe to this location and you're still holding your mouse button down, if you scroll with your mouse wheel or if you use the arrow keys on your keyboard, this red dotted line will change, and that will give you additional options to show you what this later picture will look like. So if you don't want it to be drawn this way, you can hold your mouse button down before you let go of that point, and then maybe the pipe can go this way instead. So that gives you a lot of flexibility when you're drawing your system using the ISO grid. Here's another way that you can draw your system that takes use of that new format. You can draw your system and have it look very nice. Here's the cool thing is if you look carefully, these elbows are different than before because they are actually able to point in the proper direction with the pipes. So we came out with a few additional customization icon options. That way, when you're using the ISO grid drawing format, you can still have your icons point in the direction of the pipes. Same idea here. In this particular way, I've got my spray nozzles pointing into the pipes as well. And so that's just an additional customization icon that you can work with. Okay, I believe that my XTS simulation is done solving. So let me go back to the model here. Okay, so when does the valve close? Well, look at that, 107 minutes. Well, that's weird because I didn't change the geometry. The only thing that I changed was allowing 20 feet of liquid height in the discharge tanks rather than 15. So what's going on there? Well, if you go to your graph results window and I regenerate that same graph that I had before, here's what's going on. You need 20 feet in both tanks. So as you can see with the blue line, in 120 minutes, your second discharge tank never reaches 20 feet. However, the first tank, that gets to be over the 27-foot threshold. I want to make sure that that tank does not overflow. That's why the valve shuts off, is because it's using the other criteria to shut off the valve if either of these two tank liquid heights gets to be too high, above 27 feet. So that's how you can do multi-condition events in Fathom XTS. Allows a lot more flexible flow modeling for doing your transient analysis. And that same capability for multi-condition events will be available in Impulse 7 when that is released in the next few months here. Let me switch back to the ISO grid here real quick. That way I can show you how you can access those customized icons. So here's a brand new workspace for Fathom. So if I go to the Arrange menu, this is where you can change your pipe drawing mode. The old-fashioned way, two-dimensional freeform or orthogonal. Here's the new one, isometric. Then you can show your grid. So as I mentioned, if you're drawing a pipe from one point to another, you can see that red dotted line. If you move your arrow keys, you can see how that red dotted line changes. Really cool. Well, if I put a valve right here, I don't want that valve to look like this. So if you right click on the valve to customize the icon, this is how you can change that way that it points into the pipes. You might need to rotate it a little bit. So when you select it, you can rotate it around. That way, if you're dealing with elbows, it'll fit a lot better when you rotate the customized icon like that. Okay, enough on the ISO grid stuff there. Primary windows. Colored scenarios here is a way that you can have a better way of keeping track of what scenario you are dealing with based upon colored schemes. Zoomed in way too much there. All right, so here what I've done is I've gone to the Tools menu and opened up my user options. So under user options for Workspace, if you go to colors and fonts, this is where you can change your different colors depending upon what type of scenario you are in. So this is going to color code the scenarios based upon your base scenario, a grandparent scenario, a parent scenario, and a child scenario. So it can go as far down in generations as you want. And so this is really nice because when you color code things like this, anytime that you go and switch to a different scenario, the color will change. That will give you a really good idea of just alerting your attention to which scenario that you're located in. All right. Moving right along here. Primary window features. So as I mentioned, there's a new feature that will dictate and show you if you have a additional pipe fittings and losses. So you've always been able to go in and go to the fittings and losses tab and lump in your minor losses into a pipe itself. Here's the new thing is this ampersand, this will tell you if you have additional fittings and losses on that pipe. Really good visual indicator to give you a little bit of information of what you have in your model. All right, a couple other things with model data window. If you go to the model data control, there are some additional input parameters that you can add to your model data. That way you can see a tabular format for all your input information there. Other things that you can do is if you are in the model data window, you can right click on a row just like this, and if you click on Find on Workspace, it'll take you to that particular object on the workspace itself. And so one of my later models I might be able to show you what that looks like. So those are some new features that are available in the model data window. If you're in the visual report window, the visual report control is a lot more user-friendly when you are on the Show Selected Pipes and Junctions tab. The visual report is where you can overlay output data directly on top of the model itself. There's a lot of things that can be shown. The pipe number or the junction number, you can show a name, you can show the data that you've decided to display, or the graphical pipe or junction itself. Well, before there was just a series of X's in this area, and it was kind of difficult to be able to figure out what was what. So what we have done is we've gone in and we've color coded each of these different columns. That way it makes it a lot easier for you to be able to figure out if you're toggling and off and on these different checkboxes, if you're doing that for data versus number or the junction or the name itself. So a little bit more user-friendly on that for your visual report there. Okay, so here's what's going on. There's a few more things I want to show you, and the webinar is set to go for an hour. And so I know that all of your time here is valuable, but if you want to learn about the new features, right now this is the best way of being able to learn about them and see them in action. Because right now this webinar, this is going to show you basically just about everything for the new stuff. So if you have to head out early, don't worry, I won't be heartbreaking. I completely understand because we've got 5 minutes till the hour. I'm going to keep going until I'm finished. All right, so if you need to leave early, perfectly fine. Just keep an eye out for that recorded version. That way when you get the recording, then you can speed up to 55 minutes into the webinar, and then you can watch the last few minutes at your leisure. That way you can see all the rest of the stuff that I'm going to show next. So I anticipate maybe going over about maybe 5 or 10 minutes, so just hang with me. If you want to stay on, I'll be glad to have you. If you need to head out early, thanks for listening, and I'll see you next time. And then keep an eye out for the webinar. That way you can watch the rest of the presentation later at your own time. Okay, so moving on. Piping new features. If you were to click on the pipe material drop-down menu and you keep scrolling, here's where we've included new DIN and EN standards. So there's some additional pipe materials that you can work with. Next thing is there's a new option when it comes to using intermediate pipe elevations that makes it much, much easier. So let me go and open up my model for that. Let's see, using intermediate pipe elevations and split pipe. Okay. So here's a system that I have built where I've used a whole bunch of junctions to document my elevation changes throughout that profile. There's a much, much easier way to account for all of your different elevation changes in a system without having to draw all these individual pipes and extra junctions. Okay, a much easier way is instead you can draw one pipe like I've done here. I simply used the segmenting tool that we've had for a long time to put each of these different segments in. So that's not new. The way that you do the segmenting is if you go to the arrange menu and then well, you have to select a pipe first. If you select a pipe, go to arrange, pipe segments. This is where you can add these different segments to make it look like that. So I've opened up my pipe here. This pipe is 1,016 feet long. I have a spreadsheet that I have my intermediate pipe elevation information in. I'm going to show you that. That way it'll give you a little bit more context of what's going on. So if you go to the optional tab and toggle this box right here to use intermediate pipe elevations, you would specify how many intermediate points there are. And then you can choose point to point or length along the pipe. AFT has always had the length upon the pipe option for the longest time. So here's my data. This is where I tracked each individual segment. So from the regular two-dimensional grid, I said in the X direction, one square is 25 feet long, and then the Y direction, it's 5 feet long. So I kind of made my own custom scaling for this model, and that way I could figure out my X component and my Y component. This is the total individual length for each pipe segment as I go along. Okay. As mentioned, Fathom has always had the ability to do length along the pipe, but this is a little bit more complicated because what you have to do is, in addition to figuring out all of these end elevations, you have to do a cumulative fashion of pipe length over that flow path. And that's a little bit more tricky to do versus an easier way is when you're going through, let's say that you're trying to map this out from a drawing. Well, it's a lot easier from your drawing to figure out the length from each of these different points. And that way, when you put it into your spreadsheet, you would be able to generate your point-to-point length a lot easier. So you can create this data in Excel and then count up how many intermediate points you want. If we go back to the Fathom model, excluding the inlet and the outlet, I have 10 intermediate points. So the inlet elevation and the outlet elevation are automatically picked up from those two junctions. All right. So if I open up this pipe here, I can go to my output or my optional tab, and I choose 10 points, because that's how many I have. I'm doing point-to-point length. I simply went into my spreadsheet and I copied this data, and then I just pasted it right in. And that's what my profile looks like. Very simple, very easy. So those are two different options that you can do now. You can do the option that was always there for doing a cumulative length along the pipe, but now you can do an easier way of point-to-point along the pipe. Now, let's say that you want to, you build that whole long profile and you forgot that there is supposed to be a valve somewhere in that pipeline. Well, you've always been able to split the pipe by holding the shift key and dropping a junction right on top of a pipe, but there's a more streamlined and intelligent way of doing this. Before, if you were to split this pipe with a component like that and turn it into two pipes, it's by default going to do it directly in half. You cannot control the pipe split ratio. Now, you can. And if you've got additional fittings, you can pick which pipe you want to put those fittings on. So let me show you that. And it'll also take this into account when you're using your intermediate pipe elevations. So if I go back to my model here, here's my scenario where I'm going to split the pipe. This top system, this is where I have done the point-to-point version. The bottom system is where I have done the total length along the pipe version. If you're splitting the pipe, it might be a little bit easier to do it this way because you might know where your junction needs to be rather than just in the middle of this. So here's how this would work. I'm going to hold the shift key down. I'm going to drag a control valve. I'm going to put it right on top of that pipe right there. So when I do this, I can use this scaling tool to decide how I want my pipe split ratio to look, or I can type in an exact value. So let's say that this is 972.5. Click OK. This splits it up into two pipes. Now look at this. If you go in here, it updates that length as well as your intermediate elevation data. And then this one is also updated accordingly. Now, I didn't, where I put my valve, I actually, I put it right, here graphically, but in reality, that pipe is right in this segment here. So I didn't put it in the right place. But as you can see, when you're splitting the pipe and you have intermediate elevations, it's going to take that into account. It's going to automatically adjust it for you. You don't have to worry about anything with that. Lots of user friendliness there. Okay, last thing for piping is heat transfer. So let me open up the heat transfer model here real quick. We're getting close, so thanks for bearing with me here. For heat transfer, there are some new thermal models for your pipes. So if you open up a pipe and you're modeling heat transfer, you click on this drop-down menu, and this is going to be where you can pick which one you're using. Convective heat transfer with heat flux. That's always been there. This is a new one, convective heat transfer with heat tracing. So if you have coils around your pipe that are keeping it warm or something, this is how you can account for the heat tracing as a heat flux. The other new one is buried pipe. So I've got three different systems. This pipe right here, I'm using a convective heat transfer thermal model, but instead of using the user-specified correlation for calculating or for entering my heat transfer coefficient directly, I'm having it be calculated. So if I go back into my pipe here, you can see that for the external heat transfer coefficient, I've used correlation, and there are some different options here that are available for you. and I specify my fluid temperature and my fluid velocity. So the outdoor temperature is 50 degrees Fahrenheit. I've got a wind speed of 20 miles per hour of air. You can do it of water. Maybe your pipe is submerged somewhere, and that will calculate your heat transfer coefficient for you along the whole pipe based upon that correlation. The bottom pipe situation here uses the buried pipe thermal model. So I've chosen buried pipe. You've got your internal fluid correlation, conduction to the pipe wall, and then your soil. So you would put in your soil surface temperature, your buried pipe depth, and then your thermal conductivity of the soil itself. So now I run my model, and I can see that I have my outlet temperatures of, here's my outlet fluid temperature. So 105 degrees, 147, and 149. So that's the new heat transfer modes that you can do if you're working with, for example, a convective heat transfer and you're doing the wind speed rather than a direct external heat transfer coefficient. And then here's the results diagram for when you're using buried pipe. As you can see, buried pipe, that temperature changes very, very little, even when you've got a super, super cold day out there. All right, now we're finally getting to some really fun stuff here. New Excel importing. So you can import Excel change data just like you've always been able to, but the new thing is that there's a template available for you, which is located in the AFT Fathom 10 application folder. Here's my advice. Copy this file, paste it somewhere else on your computer, okay? The reason why is because this is the file that comes with the software. You do not want to change this file and muck it up. So copy it and paste it somewhere else, and then work on that file that's saved elsewhere on your computer. That way you can preserve the full functionality of that file. This dramatically improves the importing capabilities. So here's an example of what this looks like. I have a system here of a model that I'm going to open up, and all I've done was I've laid out the model. I've built all the pipes and junctions. I've not defined any input information for pipes like material, size, type, pipe length, etc. Okay. What I want to do is I want to create an Excel spreadsheet to import all that information all at once. And it does so in a beautiful fashion. So my first step, I built the model. The second step is I set up my desired scenarios. So here I have several scenarios that I'm working with. One is where I'm keeping my flow control valves failed open, and I'm adjusting the pump speed of each scenario, 95%, 90%, 85% for each pump, okay? The second set of scenarios is where I've still got my control valves failed open. Instead of using pump speed, I'm using pump flow set points, okay? Finally, the third scenario that I've done is I have used 100% speed in the pumps, and in this case, I'm changing the flow set points with the control valves. So what you need to do is, after you build the model and you set up your scenarios, you have to prepare the respective parent scenarios with the type of data it needs. So what I mean by that is the example of these scenarios using pump speed. What I had to do is I had to double click and load this parent scenario, and instead of using 100% speed, I'm going to import Excel changes to automatically update the speed for each of those pumps in those three scenarios. Okay, now your pumps are naturally going to be set to 100% speed by default. So when I created that first scenario tree, I didn't actually have to do anything. But in the next scenario tree, I did. In this tree here, instead of using the pump speed, I had to go into the variable speed tab for each of those pumps and change them to a volumetric flow option. And you can do that globally. So I didn't have to do it for one pump at a time. I did a global junction edit, and I changed all of them to use a pump flow set point of 100 gallons per minute as a dummy value. So hopefully you can get and see how I had to go in and modify the parent scenario for each of the children scenarios. That way, when I bring in the Excel import changes, it'll automatically update everything for me. The next thing I need to do was update the piping information for material, size, type, friction model, and length. All right, we're getting close here. That's easy to do with a base scenario. And so when you're going to do the multi-scenario input changes, there's a really useful thing that you can do where you can right-click on any of these scenarios in the scenario manager, and you can save the scenario names or the whole scenario path to a text file like I've done here. The reason why this is useful is because you're going to need it for the Excel workbook that you're using for importing that change data. So let me go ahead and open up that spreadsheet here. Let's see. Looks like my audio just cut out. Can you hear me now? Julie, am I still on? Hello? Hello? Are you hearing me? Testing, testing, testing. Brian, Carl, thank you very much. All right, I appreciate that. Glad I'm coming through loud and clear. All right, let me keep going through this here. All right, so importing Excel. Here's my workbook that I used for those changes. Let me drag it over here. Well, hope my computer is not just freezing up. There we go. Okay, so here's our new template. This is really cool. This gives you instructions on how to use this spreadsheet. As I mentioned, you don't have to remember codes for anything. You can click on these drop-down menus, and that way you can set up your changes accordingly. Here's the scenario path. All of my piping information is going to the base scenario. That piping information for nominal size and type and whatnot, that's going to propagate down to all my child scenarios. Where did my model go? Oh, I haven't opened it yet. Okay, so let me open up my model here. Okay, so while that's opening, let me scroll down here. As you can see, when you specify your comments, it makes it a lot easier to see what's going on. So here's my 100%, or here's my speed changes for these scenarios. And then here's my pump flow scenarios. As you can see, you have to specify which scenario you're applying these changes to. That's why when you export the scenario names to a text file, it makes it really easy to be able to import all these changes. So when I go to my model here, here's my base scenario. As you can see, I don't have any piping input information. So I'm going to do a quick global pipe edit. And for all my pipes in the base scenario, it's going to use steel material. I'm going to start off with a guess of 4-inch and 1 foot. So when I do this global edit, this sets up dummy values for my piping characteristics for all my scenarios. Now, let me go ahead and import that Excel change data. Excel import. And this is going to automatically update all of the information in each scenario. So now, if you pay attention to what's going on in the bottom left-hand corner, you could see that it's reading in each row of data from the Excel spreadsheet, and then it's going to automatically populate each of these scenarios with all of that information. So this makes your model definition process very, very easy and streamlined, especially when you're trying to update massive amounts of data for different scenarios all at the same time. All right, it's getting there. It's almost done reading all of the scenarios in. And then you can see how my screen is changing now. It's updating all that information and for each individual scenario. And then pretty soon, we're going to see a window that contains a summary. So the following 99 changes were made. These are all my rows of Excel that were read in, and you can see all the changes that were made. So now, if I go to this scenario here, you can see that you've got all of your piping characteristics. Some are 6-inch, some are 4-inch. You can see how all of the length changes were applied. And then if we go to the pumps, you can see how I've got 400 gallons per minute here, 400 gallons per minute here. And then for my flow control valves, all my pumps are operating at 100% speed, but it's my flow set point, 1250 gallons per minute, 1250 gallons per minute. So saves you tons of amounts of time. That's Excel importing. Very powerful capability. Once you've done it and you understand this format that you need to build it in, quick and simple. Excel exporting. So we have a new Excel export manager that allows you to spit out output data to an Excel spreadsheet. So let me open up a very simple example here. Oops, I did not want to save that model, but that's okay. So here's my Excel export for the simple model. All I've got is just a flow through a pipe. So in order to do the Excel exporting, you'd have to open up your Excel export manager and then click on open. And once your Excel export manager opens, you would add in a new row. This is the data that you're going to export. So I'm doing a single value for piping results. And let's say you want volumetric flow rate. So you scroll down for volumetric flow rate, and then you could put you could change your units that you want it to be exported, which Excel sheet that you want it to go to, and then where in that sheet that it needs to go. I'm actually going to skip this example. This is intended to show how you go through the process of setting up each row. I'm going to skip to just showing you the completed version of the complex example to show you how powerful it is. This will give a lot more bang for the bust. So here's a situation where I have a pump that's specifying a heat transfer fluid to each of these different outlets, tools perhaps, and my Excel export manager is a lot more complicated because I have 3 different scenarios where my pump is operating at 100% speed in the base, 95% speed, and then 90% speed. So if I go to open up my Excel export manager, here's where I have everything set up. So it's going to export the model title. I've got some valve summary information. So I'm going to export the junction name. I'm going to export the volumetric flow rate through the valves, as well as the K factor for the valves. And I want the temperatures of the outlet of each of those pipes to be determined. So I'm not showing the results for all pipes, just the temperatures for all of the outlet areas there. The next thing is I have a couple of graph list items. I've got a couple of profile plots as well as pump and system curve plots. So all this here is set up, and when I go to run my model, or it's going to do a batch run, it's going to create a Excel spreadsheet for me. For guidance on this model, read this blog. It's in our tips and tricks articles area. This will show you actually how to go about setting up the Excel export manager. I tweaked it just a little bit for my demonstration. So what you'll see in the blog is just a little bit different than what I'm showing here. So I'm going to do a batch run. And for my batch run, I'm going to run all 3 scenarios. I'm going to send the results of those scenarios to the same workbook in different tabs. So when you start the run, it's going to run each scenario individually, and then it's going to spit out that data to an Excel spreadsheet. And it looks really nice. So it's setting up the Excel export for one scenario. It's currently exporting the graphs. Right now, it's exporting a pump and system curve. Then it's going to do the same thing for the next scenario. Now, while that's running, I'm going to open up a pre-formatted version that would show you what you can do after the fact. One question here that I see that I got is, do Excel import and export functionalities work with Microsoft Excel version 2016 64-bit, or are they just tied to 32-bit? This should work for both 32-bit and 64-bit. If you have any issues with anything, email it to support@aft.com and let us know what the issue is, and we'll diagnose that and help you. Okay, this is almost finished exporting here. As you can see, I've got several spreadsheets already open, and it looks like it's done. So with it being finished up here, my computer is freezing on me. Let me close out some of this stuff. Let's see. Okay, well, I think that one of the things is if you are trying to do a whole bunch of things at the same time, that can bog down your computer and cause some issues. So let me close Fathom. Open up my task manager. Because what I want to do is I want to show you what it looks like after the fact. So this is a pre-formatted spreadsheet that I made. So essentially what you would see is something that looks like this. Is when you go through and export the data, you're going to see an export guide spreadsheet that tells you what happens. Then it exported all my base scenario results into this tab, and then my 95% results in this tab. So you can see you've got your valve output data. These are my outlet temperatures. This is my pump summary data that I exported. These are some flow path graphs that I exported. And then here's my pump and system curve information. Here's why this is so powerful, is because you can have all this data be exported in this fashion, and then you can do something cool like this, where you create a pump and system curve family graph, which will plot the pump curves for the affinity laws at those different speeds all together at the same time. So this is just one of the ideas that you can do for exporting data, especially if you have multiple scenarios. And using the batch run feature is the most useful for that. Okay, time for the moment that you have all been waiting for, is model integration and importing. So what can we import? Piping component files. Okay, if you're working with Plant 3D or AutoCAD or CADWorks, or any type of drawing software that can create an isometric drawing and a ISO with Isogen, you can generate a piping component file that can be read into Fathom and Arrow 7 for that matter now, and it will build the model for you. Other things you can import is Caesar2 neutral files, EPANet files. You can also use Fathom to export a model to an EPANet file. And you can import GIS shapefiles. The GIS has been available since Fathom 9. This is automatic model layout building that will give you massive amounts of time savings. So the way that you do it is you would just go to a blank workspace of Fathom, go to File, and then import your piping layout. Pick which file you're going to import, and there you go. So let's do it. I'm going to open up Fathom here. Brand new capability, really cool. It's going to save you tons of time. And here's how it works. So I'm going to start off with my piping component files first. So once Fathom finishes running there, a bit of advice while this is running is if you are constantly opening up files without ever closing Fathom down, that can cause your computer to run out of memory. And so that's probably what my computer was having problems with when I was dealing with the Excel export is I kept opening up new models or existing model files without ever closing Fathom. And so that can get kind of finicky sometimes if you're doing a lot of different things. All right, so you go to File, Import Piping Layout, Piping Component File. So you would pick where your files are located. So on my computer, I have saved my files in my desktop, which is right here, Fathom 10, official files, model importing. So here's my two PCF files. So I've got two of them there. When you click on a PCF file, it's going to give you this preview view. As you can see from the preview view, it's going to show you what the models look like. So you've got a valve and an area change, some elbows. You can see the piping. And so this is what your model looks like. It contains information about the object in the PCF file, and then it's going to tell you what you want to try and import it as. There are some different options down here where you can import elbows as pipes. Maybe you don't want to do that. And so this is going to give you a lot of flexibility and control over how you import things. So maybe this particular valve right here is not an actual valve. Maybe it's a control valve. So you can specify what type of junction it is. And that way, when you import the data, and you bring it in, it looks just like this. Now, here's the other thing. Maybe you don't want to import just one PCF file. Maybe you've got multiple PCF files that you want to import to the same workspace. As you can see, there's my control valve. Well, I can zoom out and I can select my other PCF file and I can import it as well. So I can drag this, this is where I want it to go. And then I want to import this in the same way. And so now when I import that, it's going to draw out the whole layout for me. Now, as far as input information goes, currently we are importing pipe inner diameters and lengths, okay? So if I close this window here and I go to the Model Data tab, you can see that it's importing my pipe lengths and my inner diameters for these objects, okay? Eventually, we will be importing elevation data as well. So the important thing that I want to point out is, well, I'll point out later, if I select all there's intermediate points, some places I want to clean it up, I can just do none. That way it really cleans up the model nicely for me. And so that's PCF importing. Let's do Caesar2 neutral file importing. So I go to the same area, File, Import Piping Layout from Caesar2 neutral files. So here you would do the same sort of function of picking your location of where your Caesar2 neutral files are located. And I thought that I had a couple files in there. Maybe I only have one. So here's my Caesar2 neutral file, and this I think comes from a Caesar example. Maybe I don't remember, but you build that in. You can import your pipes as elbows, or you can just import them as pipes. Now, if you don't want your junctions to be there, you can just have them be lumped in as pipes instead. And it's got your scaling options there. Here's the thing I want to point out is whenever you're importing a PCF file or a Caesar2 neutral file, if you have troubles or ideas or suggestions, click on this troubleshooting option. This will take you right to our website where you can email us at support@aft.com. You can describe to us your situation, any difficulties that you're having, or ideas that you have. That way we can continue to improve and make this better over time. So here's my Caesar2 neutral file import. As you can see, saves tons of time rather than having to use the old drag and drop. All right. One more is my EPANet files. So if I go to New, here's what the EPANet looks like. EPANet is a free software made available by the U.S. government. It's used a lot by the water industry. And so the key thing about these neutral files, PCF, Caesar2, and EPANet is it allows you flexibility to go between different software programs. So if you need to take a CAD file, you can just do it like how I've been showing you. All right, so here's one EPANet file, and it imports that. And as you can see, it builds the model very quickly. And the EPANet files actually will import some additional input information, lengths, diameters. If I look at my junctions, it's got elevation data. If you go to the pump, it actually contains pump curve information. So whatever information that is contained in that EPANet file, it's going to bring it in. Eventually, the PCF and Caesar2 neutral files are going to import a lot more information as well. And then here's one more. Well, I went to the wrong spot. So the other EPANet file that I have looks like this, where you just go down here, EPANet file, and then for my desktop, it's in my new features webinar. And here it is. So import. This is a much larger model. And so as you can see, it's going to save you tons and tons of time. It's fairly robust and easy to work with. Let us know your feedback and have fun working with these new features. As you can see, it's really fun to watch the model build itself. And look at that. That is beautiful. When you're doing this model importing, you might be using the Workspace overview map a lot more, where you can get a bird's eye view of your system. You can create that viewport and you can zoom into those parts and drag it around. That makes it really easy to traverse around your model and zoom into different points. All right, well, that is what I had for you all today. And so for those of you that were able to stick around, thank you very much for your time. And if you're for those of you that are listening in later, enjoy the show. If you have any questions, please do not hesitate to contact us, support@aft.com or sales@aft.com. My presentation should be available to you all, but if you're listening in later after the recording, email me at benkeiser@aft.com. I'll be happy to send you a PDF of my presentation. Thank you all very much for the extended webinar, free of charge. And let us know if you have any questions, and have a marvelous rest of your day.